So at that situations, we try to move on machine learning algorithm. Sometimes the models must be customized. So nowadays, the customer behavior pattern is frequently changing. So just we try to adopt how the people's customer behavior patterns are changing with the help of machine learning. Then models are based on huge amounts of data is the another major critical issue. So nowadays the peoples cannot process the small amounts of data because each and every day the peoples are going to generate huge volume of data through social media. So it's very tough to process the data. So at that situations also we need machine learning. But what the real issue? So whether we need machine learning in all the times, so there is not much that level. So learning is not always useful. For example, if the people wants to create simple table creations, result analysis, that kind of situations, no need to use machine learning. So this is the machine learning process. Normally, seven different kind of steps we are following for performing a machine learning process. The first step is gathering the data. So what's meant by gathering data? The simple thing, machine learning do some process is to get a data. So for that purpose, we need to collect a data from various sources. So the data collection, it depends on what kind of data we gathered and where is the source of the data. So both are very important. So because the quality of the model determine how the accurate the model is. So that's a very important thing. The quality of the model is 100% depend on what kind of quality of data we are going to provide or we are going to feed. Then followed by the next very important step is preparing the data. Once we collected the data, how we are going to prepare. So what's the real issue? The data is often unorganized, redundant, or missing some elements. That's a major issues. So for that, just we try to clean the data and prepare and manipulate the data. So for that purpose, we are going to perform different kind of data cleaning operations. Once data cleaning operation is completed, after that we try to convert the data into record format for further process. So the third and very important step is choosing model. So based on the data availability, we are planning to choose which machine learning model is suitable for our given problem. So the model is indicate because each and every time the algorithms may give different kind of predicts. So we try to adopt which model is suitable for the given data. So we try to choose appropriate model. Then after that, we try to train the model. That's a very important thing. So in these situations, so the prepared data must be classified into two different categories. One is training data, another one is testing data. In the early stage, the data training and test data must be classified into 50-50, then later on 60-40, then 70-30. Nowadays, the people are divided the data into 80% for uh, training data, 20% for testing data. So once the data is prepared, so the which kind of machine algorithm is used on the training data set to train the model. So any ML algorithm leverages mathematical modeling to learn and predict the output behavior. So that's a predict behavior. So once the prediction is process is prepared or completed, then we are going to check with the evaluation steps. So in the evaluation, just we are trying to use a different kind of performance metrics. So nowadays more than 16 different kind of performance metrics are there. So these performance metrics are used to evaluate the uh, prepared model. That's a contractor model. So what's the model we constructed? What's the model? That's a program. So that we are going to evaluate. So based on the outcome, whether we go with the same output, otherwise whether we are going to perform some hyperparameter tuning. So nowadays the people are using hyperparameter tuning because in generally think if you are feeding some parameters, the parameters normally used to allow the model to learn the rules from the data. That's the only purpose we use the parameter. But nowadays, the people are using hyperparameter tuning. So hyperparameter tuning is how control the model is training. So while training the model, it's going to check and control the model. That's the only purpose we go with hyperparameter or tuning. So the parameter, in generally speaking, it's automatically learn their values from the data. But hyperparameter tuning is not learning anything from the data. It's trying to control how we are going to construct the model. For example, if you go with support vector machine or regularization parameter, just we are feeding, controlling the trade-off between the maximization and maximize the margin, and how we are going to minimize the classification error. So that's the only thing, just we go with hyperparameter tuning. The finally predictions. So prediction is the final and very important factor. That's the outcome of the entire process. So the output of and which machine and algorithm we use after it has been trained as a historical data set, and just we try to apply it to a new data when forecasting the likelihood of a particular outcome. So what the outcome we are expected? So we are expecting outcome satisfied with the existing predictions. We accepted the process. So this is the 7 steps machine learning process. 10. So based on the previous slide, just here we are going to show how does the machine learning works. Here, just we prepare the data. The data may be classified into some portion is maybe 80% is a testing data, training data. That training data used to train the ML algorithm. So the outcome is model constructions. Once the model is constructed, that is the outcome of the program is treated as a model. Once model is constructed, after that we are going to check with the remaining data, that is called the test data, and also sometimes we are going to testing with the new observations from the outside. So just we are going to test the data, then we try to check the outcome. The outcome is the prediction, whether we are going to check the outcome is satisfied with our acceptance level. If the accuracy of the prediction level is okay, then we are accepting. Otherwise, again, we are going to train model. Just we are going to change some input parameters. Again, we are going to change some model constructions. Again, we are going to change some different kind of machine algorithm used to construct the expected output predictions. So in this case, a machine learning based system is not explicitly programmed, but learned from the data. That's a very important thing. So no need of creating a new things from new programmer perspective. Just we are going to construct the model from how the things, how the machine algorithms learning from the existing data. Once the algorithm is constructed, it infers patterns and relationship between the two different kind of variables within a data set, that uses the knowledge to generalize beyond the training data sets. So some of the text context may be used in the machine learning frequently. So one is feature, the second one is labels, then third one is models, then accuracy and precision. Well, features. In generally speaking, a feature represent an independent variable. So suppose if the data set may be representing in the format of tabular column, so yeah, each row may be represent an observations and column may be represent a feature. So a collection of features or a group of features are collectively referred as a dimensions. So in the later stage, we try to perform some a dimensionality reduction technique. So at the time, just we are trying to check what kind of feature is, whether it is the dependent feature or whether it is a independent features. So these are things we are going to consider while constructing the machine learning algorithm. So the features may be classified into two types. One is categorical features, another one is numerical features. So the categorical feature is it may be again it's a fixed number of discrete values with name or label. Just we are trying to, for example, if you want to define some uh, discrete values, example, different kind of designations, different kind of habits, behavior, gender specification. Just we are trying to use categorical features. So the numerical features, it's a numerical value. So numerical feature have mathematical ordering. So we able to specify some specific ordering per numerical feature. So again, it can classified into two types. One is a discrete numerical feature, another one is continuous numerical feature. The discrete numerical feature, the example is how many number of persons, what's your exact salary, something like that. But the continuous numerical feature, continuous values like temperature values, pressure values. So these things should be under continuous numerical feature. Then labels. So label is the very important terminology used in machine learning algorithm. So here the label is a variable that a machine learns to predict. So the definition for label is a label or a tag is simplify and identifying an element that explains what a piece of data is. So just with the help of label, just we try to explain and we try to disseminate the information about a particular data. So the label again can be classified into categorical label and a numerical label. So for example, if you are going to specify some news article, that should be treated as a categorical label. For example, if we able to specify the quantitative values, that's a numeric quantity value. Example is price. Then models. So generally speaking, model is a program. Say a machine learning model is a program that is used to make some predictions for a given data set. That's a simple thing, model. So the model must be built by machine learning algorithms. That's why here they are going to give some clear definition for models. So here model is going to perform three things. The first one is a mathematical construct for capturing patterns within a data set. So first we try to find some data sets within the given data set, then and estimates the relationship between the dependent and independent variable. Just we try to find the association between the two different kind of variables. And third, the predictive capability and can calculate or predict the value for dependent variable when get the value of the independent variable. How the independent variables may be extracting some kind of new predictions from the existing things. That's a model. So here the training a model is a compute intensive task. So that's a very important thing. So while we are going to construct a model, just we need to train a model. For that it is a little bit intensive task, but while using it is not a compute task. Just we are going to, once model is constructed, after that we are going to perform a testing process, or there we are going to feed a new kind of data into the constructor model. It is not a tough task. So again, what kind of data we are going to use? Here we are going to use two different kind of data. One is training data and test data. Already we discussed. So nowadays the people are using 80% of preferred data using for constructing the model. So once model is constructed, after that they are going to use 20% of data may be used for testing the data for checking the performance metrics of our predicted model. Yeah. Then a difference between accuracy and predictions. Another very important performance matrices for accepting or not accepting our predictor model. The first thing, accuracy. So accuracy is how close a measured value is to the actual values. That's the thing. Just suppose in the confusion matrix, just we are going to get a lot of our predictions. So in that case, just we try to check the measures how often machine learning correctly predicts the outcome. So that's something related to the accuracy. That's a sense. Total number of correct predictions divided by total number of predictions. So just we are going to check the percentage of how many number of correctly we predicted from the total number of predictions. That is accuracy. So in the precision, how close the measured values are to each other. So what the way the predictions must be close with each other. So again, the formula is the number of number of true positives are divided by total number of predictions. That is true positive plus false positive. So sometimes we correctly predict the positive things. At the same time, we sometimes predict negatively also. That should be combined together. So the both performance metrics are used to specify what kind of quality of our model is. Types of machine learnings. So the entire machine learning is classified into 4 different categories. Now it should be classified into 5 different categories. So the first one is a supervised machine learning. Then second one is unsupervised machine learning. Then third one is semi-supervised. Then fourth one is reinforcement learning. So nowadays deep learning also considered as a one kind of machine learning. So in the supervised machine learning, so label must be used. That's the sense. If the gathered data are very familiar with us, then we go with a supervised learning. So because we are familiar with some of the known labels, some of the known tag, or some of the uh, known names, then we can easily construct the machine learning. That kind of machine learning process is treated as a supervised machine learning. In the unsupervised machine learning, so without unlabeled data, without knowing the informations about the data, without any experiencing, without knowing the informations about the data, just we try to finding a new patterns, we try to finding the new features in the existing data pattern. That should be treated as a unsupervised machine learning. In the semi-supervised machine learning, it is a combination of supervised machine learning and unsupervised machine learning. So in this kind of machine learning, just we try to use some of the known labels along with some of the unknown unlabeled data sets to train the machine learning algorithm. Then reinforcement learning. So it's like a customer feedback process. So in the reinforcement learning is a feedback based process, just where we are going to apply the machine learning, just we are trying to get some feedbacks. The feedbacks may be a different kind of feedback mechanism is there. Based on the feedback mechanism, we each and every time we are going to uh, change the training model, and finally we get it the expected output. In the fifth terminology not showing here, the deep learning. So deep learning normally used to the extends the concepts of neural networks. With the help of the neural network, just we are trying to construct a different kind of models. So one is convolutional neural network, then deep neural networks, then RNN, recurrent neural network. So is a simple example showing supervised learning. So in this diagram, so some of the vegetables are familiar with us. So just we able to provide the labels. Just we are trying to train the model, and we can easily predict the outcome. So the best example for supervised learning is classifications and regression models. In the unsupervised learning, without knowing the data information, that's why it should be treated as unlabeled data. So what's the real issue? So this kind of situations may occur. We try to use entire data set for further process. So compare with the supervised learning. So in this kind of unsupervised learning, take a little bit more time for training the model, because without knowing the gathered data informations, we are trying to predict the outcome model. For example, in the before corona period, just in the initial stage of the corona period, it's very difficult to find what kind of impact, what kind of uh, data may give more impact on corona infections may issues. So at the time that people are simply applying different kind of machine learning, unsupervised machine learning algorithm. So once after 2 years, nowadays the people are trying to do some corona related machine learning algorithm with the help of supervised machine learning, because some of the features are very well known to us. So they go with supervised learning algorithm. So it is a semi-supervised learning again. So based on the previous 2 slides, again they are going to combine two things. Just we gathered some preferred data, just the input data, along with some partial data. Just we try to give some known labels with smaller amount of known labels. So both the informations combined together and feed into the that's training the machine learn. Just we try to predict the outcome from the existing things. So this is a simple example of semi supervised learning. So this is the reinforcement learning. Here we are going to insist, or we are going to forcing the response. That's why it should be treated as a reinforcement learning. Just we are gather the data, just feed into the process. Just we are asking some response from the customer. Based on the customer, they are giving some different kind of uh, their experience, their inputs. Based on their input, we are going to internally check and train the model. Then finally, we are getting the needed and corrected output. Okay, here I am listed around 9 different important task categories for machine learnings. Apart from lot of tasks are there. So these are the most tasks nowadays the people are using in the machine learning environment. The first one is classifications. So classification is the best supervised algorithm used.
பண்ணிட்டாங்க. இது இது ஃபைல் கரெக்ஷன்ங்கிறது இப்ப சொன்னா அதுக மாத்தி பண்ணிடுவாங்களாம். எக்ஸல்
I
உங்களுக்கு ஏதோ தெரியல.
used to kindly mute. That is used to identify the category of new observations on the basis of training data. That's a purpose. Just we go with supervised classification algorithm. So in the classification, a constructed model, that's a program, learns from the given data sets and observations, and then classifies the new observations into number of classes. So normally it should be treated as a binary class, maybe a yes or no, or 0 1, a PAM and a PAM, a cat or dog, something like that. We go with binary classifications. So these classes are simply called target labels. So the classification may be classified into two different categories. One is binary classification, another one is multi-class classifications. So in the predictive classification, binary classification model, we get it two different kind of inputs, maybe yes or no, something like that. In the multi-class classifications, if the outcome has more than two, that should be treated as a multi-class classification. The best example is handwritten recognition. The regression is another very important mathematical tool or mathematical model. So in this model, the regression normally used to finding the relationship between the two variables or multiple variables. So in the linear regression, just we are trying to finding the relationship between only two variables. So one variable is treated as a dependent variable, another variable is treated as a independent variable. Okay. But suppose we are going to use a multiple variables, that should be treated as a non-linear regressions. Here we are generally we are talking about the regression process. So to predict a numerical label for the unlabeled observation, so then only we go with the regression. So it is a best supervising machine learning technique which is used to predict continuous values. The objective of the regression algorithm is to flat best fit line or curve between the data. So how many number of data lies on a uh, bedfish line. So based on this thing, just we are going to get it to predict. So in the regression, we are using to evaluate the trained regression model is a variance, a bias, and error. So these are the three matrices normally used to evaluate the constructed training regressions. The best example for regression is home valuation, asset trading, and forecast. Nowadays, the people are very much involving in the trading, stock trading. In the stock trading, more number of stock related built-in machine learning projects are nowadays the people are created. So this is the best example used. Regression is the best machine learning technique used in the trading. And clustering, so a cluster sense is a groups. So here we are going to divide or we are going to split the database into how number of clusters or segments or groups. So what's the important thing? The elements in the cluster, elements in the same cluster are more similar characteristics to each other than and then to those other clusters. So that's why we are going to create the cluster based on the similar characteristics. So the similar characteristics must be put it into a single cluster. So it's very difficult to predict how many number of clusters we are going to generate, how many number of clusters we are going to create. So clustering itself can categorize into two types. So one is hard clustering, second one is soft clustering. In the hard clustering, a data point can belongs to only one cluster. So here each and every data point must be present within a single cluster only. So the characteristics must be surrounded by a single cluster. But in the soft clustering, the output provided is a probability likelihood. It's maybe likelihood of a data point belonging to each of the predefined number of clusters. So some of the data points may be representing the similar characteristics between more than one cluster. That should be treated as a soft clustering. So the best example for clustering, customer behavior identifications. Nowadays, customer behavior patterns every day, every seasons is going to change. So with the clustering techniques, we are trying to identify the behavior pattern of the customers. Then anomaly detections. So just like that outlier. So anomaly detection is the best process for finding the outlier values of the series of data. Just we try to identify outlier data, just what way we are going to remove the unwanted data. Sometimes we need to give much more important to outlier data, because outlier data gives some good information. For example, if try to avoid some kind of fraud deductions using financial transactions for logging into our websites, because unusual movement is occurred, so we can easily identify anomaly detections. So that's the way we are going to use the anomaly detections. It is a process. Assume the data must fall within a certain understood range. If any kind of data must not fall within the range, that should be treated as a anomalous values. So that occasional values outside that range happen fairly infrequently. So with finding the infrequently but out of range values, sometimes used for finding some new kind of patterns. Best example is the manufacturing sectors. The manufacturing sectors, some manufactured products may not be need our uh, quality. So that kind of defective products we can easily identify with the help of anomaly detections. Then associations. So very important um, method for finding the patterns. So the relationship between the co-occurring items are expressed as associated rules. Just we try to find the relationship between two different kind of variables. So that's why here they are going to mention associated models allows you to predict which items are most likely are to appear together. So what they just in the frequent patterns, that's especially the data minings, we trying to use association rule used to construct association rules to create, to identify what kind of different kind of patterns are frequently occurred. So it try to identify the strength of the relationship between two features, two different kind of variables. One kind of variables may be treated as a dependent, another kind of variables may be independent. Sometimes we try to identify dependent variables also. So in the association rule mining is a technique used to uncover hidden relationship between variables in large data set. So that's a very important thing. Just we are going to extract some uncover hidden relationship in given database. The best example for association application is cross-selling and upselling. So we need some business knowledge to change our business strategies for improving the sales increasing, and how or what the way we are going to satisfy the customers. So that's the only purpose, just we go with association. Then recommendations. So recommendation is a very important task in the machine learning. So the goal of the recommendation system is to recommend a specific product to a user based on the existing behavior to determine user preference. Just we try to give a new kind of products to the new kind of user based on their experience. So unlike a association, it focuses on user behavior and suggests according to this user behavior, because nowadays the people behavior is frequently changing. It's very tough to identify the user behaviors. So that's the only purpose we go with recommendations. So for the recommendations is the best method for reinforcement. It is a reinforcement technique. So we not sure of result until user choose one of our recommendations, because we are not in position to give 100% assurance to user must satisfied with our recommended product. If the user may not be satisfied, user may not be accepting our recommendation, our results may be incorrect. So the best application examples are Netflix, YouTube, Tinder, Amazon are the best example for recommendation system. In the especially media and entertainment industry, the recommendation system may be classified into 6 different ways. One is a collaborative recommendation system. Then second one is content based recommendation system. Third one is demographic based recommendation system, utility based recommendation system, knowledge-based recommender system, and finally hybrid recommender system. So nowadays, almost all kind of AI apps using these kind of recommending system for suggesting and providing informations to the customer. Then dimensionality reductions. So dimensionality reduction is used to reduce the computation cost of the machine learning algorithm. So how we are going to reduce the number of features in the given data set. Sometimes some of the features may not give some impact for predicting the results. So that kind of features will be removed from the given data set. It automatically reduce the computational complexity time, and also it also reduce the cost of the machine learning algorithm. So some of the methods used in the dimensional reduction is, dimensional reduction is the general thing. So some of the uh, independent variables may not be used. That kind of variables may be removed. Some numerosity reductions. So just we are having a different kind of different range of values. That different kind of range of values must be specified in some specific range. Data cube aggregations. Just we try to summarize the data from the existing data. Data discretization. Just we try to provide some generic information from the existing data process. Data compression, we try to compress the data into two different ways. One is lossless join and lossless join. So two kind of data compression technique may be using in the image kind of data. Then data pre-processing. So data pre-processing is very important uh, terminology used to reduce the dimensional reductions. So these are the techniques normally used in the reducing the dimension. The best technique is PCA, principal component analysis. Then computer vision. Nowadays, the people's focusing on this area. The computer vision is a process. The data accurately for identifying the object and identify the facial recognition. So that's the thing. Just we go with computer vision. So after Corona, so most of the industries need to check the computer visions using facial recognitions, whether the people are properly wearing the mask, whether the people are wearing the proper gloves in the manufacturing industries. So the computer vision uses the data to make decisions and allow it to be used in interesting ways in wide variety of industries. That's the example I mentioned. The computer vision, it is a subset of machine learning that enables computers to gain a high level of understanding based on high quality videos and digital images. Some of the applications of computer visions, it's automatic. Nowadays the people are, so nowadays the automotive industries are very much focused on self-driving cars, parking occupancy detections, traffic flow, then road condition monitoring, then text analytics. So it is another important machine learning technology. So to automatically extract valuable insight from unstructured text data. So the companies may use text analysis too. So nowadays the most companies are using different kind of text analysis to quickly digest online data and documents and transform them to actionable insight. That's the readable format. So here they are going to use two different kind of text analytics tools. One is supervised learning. In the supervised learning, where human helps to train the pattern detecting model. Here 100% human intervention is occurred. But in the unsupervised learning, where the computer finds pattern in text with a minimum level of human intervention. So the best text analysis tool, sorry, text analysis example is sentimental analysis, topic detections, and urgency identifications. So this is the examples of different kind of techniques used in the machine learning types. In the supervised learning, just we go with the regression classification. In the unsupervised learning, just we go with clustering and dimensional reductions. In the semi-supervised learning, just we try to implementing some self-training, some low density separation models, then graph based algorithms. Nowadays the people are focusing on graph based algorithms. Then reinforcement algorithm, just we implementing the dynamic programming. So how we are going to divide a complex problem into multiple small problems. That's the way we are going to use the dynamic program. Then Monte Carlo methods and some heuristic methods. That's like a thumb rules. In the deep learning, just already we discussed. So computer neural networks, deep neural networks, then recurrent neural networks. So some of the famous algorithms are listed here. So some of the famous algorithms, the classification is okay, KNN K neighbors algorithm, decision tree, then SVM, then regression, a different kind of more than 6 different kind of regressions are there. The clustering, K means, DB-scan, Gaussian mixture are famous algorithms. The reinforcement learning, decision making is a Markov decision. So apart from Q learning, R learning, TT learning also there. Another very important thing. So it's a no free lunch. So no free lunch is a kind of theorem. So a theorem indicate uh, in the machine learning algorithm. So there is no specific algorithm is suitable for all the problems. So that's the sense. Each and every kind of algorithms may be suitable for different problems. Not a single algorithm is suitable for every problem. So what the issue as a result? So the people should try many different algorithms for the different problems while using a holdout. That's a test set of data to evaluate the performance and select the winners. The best example is in the stock market. So lot of indicators are there. So what the real issue? The people in the technical analysis, the people are using different kind of indicators, but some kind of indicators may be suitable for some kind of stacks only. So there is no possibility for a single indicator may suited for all the steps. So for that purpose, they go with different kind of technical analysis called Fibonacci analysis. So in the Fibonacci analysis, they are trying to identify the characteristics of the equity. Now you are raising the one question: how they are going to identify the characteristics of the equity. So in that sense, here they are going to identify the characteristics of the peoples who is involving for a particular equity trading. For example, if gold is there in the commodity market, gold is there. So if the gold trade, only the few people are involving in the gold trade. Now they are going to identify the characteristics of the peoples who are involving only in gold commodity market. So this is the way they go with different kind of machine learning algorithms used for different problems. So there is no simple or single algorithm may be applicable for all the problems. So again, ML in a nutshell. Here we are going to discuss about three important components or three important terminologies. So every machine learning algorithm has three components. So one is representation, then second one is evaluation, then third one is optimizations. So representation is the very important component for how we are going to representing the model. What the way we are going to representing the model. So here we are trying to representing the models in four ways. One is numerical functions. Another one is symbolic functions. Then third one is instance based functions. Then first one is probabilistic graphical models. So these are the representation methods are used to representing the different kind of models based on their problem and expected output. Then second and very important component is evaluations. In the evaluation, just again, we are using more than 60 different kind of performance metrics are there. In most of the time, we are using a confusion matrix to construct. Then after that, in the confusion matrix, we are trying to calculate accuracy, precision, type 1, type 2 error, F1 matrix correlation. So different kind of matrices are there. For evaluating the models. Here, I am trying to mention some of the few important matrices: accuracy, precision and recall, squared error, likelihood, posterior probability, cost utility, margin, entropy, and KL divergence. These are the very important. Already we discussed with the accuracy. In the accuracy, just we try to check how many number of correct predictions is identified with the total number of predictions. In the precision, just we try to identify how number of true positive predictions from the total number of positive and false positive predictions. In the recall, as something reverse of precisions. So in the recall, just we are going to check how many number of total positive predictions from total number of positive and total number of false negative predictions. Just we try to calculate a recall matrices. And a squared error here is the another important matrices is the one kind of error. What the way we are going to reduce the error? Just we are trying to reduce the error. Just trying to close to zero. That should be treated as a squared error. Different kind of errors are there. The best error is mean squared error. So here just we try to uh, average square difference between the predicted and the actual target values within a data set. That should be treated as a squared error. Then likelihood. So it is a kind of function tells is how likely a specific data point suits the existing data distribution. What the way we are going to distribute the given data point within the given a range. Then posterior probability, for example, if you are going to use Bayes theorem in this kind of technique, just we try to consider the prior probability information, updating the prior probability information. That also should be treated in posterior probability while constructing the machine learning algorithm with the help of Bayes theorem. Then cost utility. So cost utility is the another important factor for evaluating the machine learning algorithm. So it is a kind of measure the discrepancy between the model predictions and the values it is attempting to predict. So just we expected something, then how many number of ways we are going to attempting to predict the actual values. So that's the thing is should be treated as a cost. Then margin. So margin is the other very important evaluation metrics in the example of support vector machines. Here the distance between the data points to decision boundary. So how the data points is differentiate from the decision boundary. Then entropy. So another evaluation matrices. So the level of disorder or uncertainty in a given data set or a system, that should be treated as a entropy. So it is also one of the matrices used to evaluate the model. Then finally, KL divergence is a rare evaluation matrices. So it is a what called non-symmetric metric. So that measures the relative entropy or the difference in information represented by the by two different kind of distributions. So that area just we are trying to use a KL divergence. Apart from lot of evaluation matrices are there. Then finally and very important, optimization algorithm is the third important component for a machine learning algorithm. So here we are going to classify four different kind of optimization. One is a gradient descent. So gradient descent is the technique is used to find the uh, local minimum and maximum of a given function. Just we try to find global and local minima. So it try to minimize the either cost or loss functions. So it is a iterative process. So the dynamic programming. So in the dynamic programming, normally we studied in the data structure. Again, here we are going to use the dynamic programming. So the dynamic program works by breaking down complex problems into simple sub problems. Then later, we are finding optimal solutions to this problem. This is the dynamic technique. Here we are going to use two different kind of learnings. One is HMM. So it is a hidden Markov model. So in the hidden Markov model, it's a statistical model in the machine learning algorithm for using speech recognitions and natural language processing. In the PCFG, is treated as a probabilistic context-free grammar is a technique. So in this technique, just two different kind of variables normally used, terminal and non-terminal variables. So and also it's going to create a more number of production rules for finding the model. So in the divide and conquer is the best optimization algorithms. In this algorithm, it is a recursive approach for dividing a complex problem into more than two to three simple problems. Again, this problem is divided. So each and every time we are finding the optimal solutions and summarize the optimal solutions and to find the new solution. Is the best example is decision tree induction and rule learning. Then finally, The best optimization technique is evolutionary computation. So evolutionary computation is a trivial process. So just it is an initial set of candidate solutions is generated and iteratively updated. Just we are trying to create more number of candidate from the existing candidate. Now again, we are going to combine different combinations and finding which candidate is suitable for. So based on the evolutionary computation, just again we are going to classify genetic programming and neuro evaluation. Then, so why the people are preferring Pythons than other languages? Only these reasons is it's very easy to read syntax. It's very simple syntax. The user can easily remembering, so there is no issue. Then extensive libraries and frameworks. So the Python is providing more number of libraries, so the developer or researcher or user can easily construct a model with the use of libraries. Then cross-platform compatibility. So while you develop the model in using the Python. So it may be working in any kind of platform like Windows, Linux, Mac, anything. So scaling and performance again. So nowadays the people are using huge volume of data. So there is no issue. So Python is easily support for any kind of any volume of data and also improve the performance. Then finally, just we are trying to compare different programming language with Python. So, for example, if you are going to compare with any R programming language or Java programming language, anything, so these are the benefits from Python language. First one is simplicity and readability. So, in the Python syntax is very simple, very clear, very concise. So, it is very easy for any person. Then second one is a vast ecosystem of libraries and frameworks. So it is a rich ecosystem of machine learning libraries. So it's provide more number of libraries. For example, pandas, Python, matplotlib, cbun. So different kind of libraries are there. Then integrations and prototyping. So this is the best example. Sorry, I forgot to mention community support and documentation. So nowadays, Python has massive and vibrant communities, which means lot of resources are available, lot of tutorials are available. So more number of discussions also available in the net. The integrations and prototyping, so we can easily integrate with other technologies from the Python perspective. So for example, if any kind of web frameworks, any kind of data analyst tools and cloud services can easily integrate with the Python programming. Then finally, the performance and efficiency. So Python indirectly and also directly provide better performance and better efficiency compared than other programming language. So some of the libraries are listed out here. So first one is a NumPy, a numerical Python. So numerical Python is a fundamental Python library for efficient numerical computations and array operations. Then apart from scikit-learn, so it provides a various kind of machine learning task, just classifications, regression, clustering are directly applying. And pandas, it's a powerful data structure utility like data frames and series. So using this one, we can easily manipulate the existing data and also we are going to perform some analysis. Then matplotlib library, it is a 2D plotting library for creating any kind of graphs and plots. Again, it may be support for 3D. Then cbun is the best visualization library based on the matplotlib. Then TensorFlow. So TensorFlow is the latest cutting-edge deep learning library known for its distributed computing capability and robust ecosystem. And Theano is a Python library designed for fast numerical computations, particularly useful for training deep neural networks. Then Keras, again, it is easy to working in deep learning API, so application programming interface that act as an interface for TensorFlow. Again, we can easily combine with the TensorFlow, Theano, and also CNTK called Microsoft Cognitive Toolkit, then PyTorch. So PyTorch is a dynamic deep learning library with flexible computations graph, making it ideal for developing and any kind of training complex neural networks. So these are the free data sets for machine learning. Everything's available. So 65 plus best free data sources available in the V7 labs up to 2023. They updated. So nowadays, more number of people are using only Kaggle is the best open source. Then best public data sets for machine learning is updated up to 2024. Then 50 different kind of public data sets for machine learning projects used in the ML4 dvs.com websites. Then apart from, so these are the capstone projects are created and available in the free source. Just more number of people are very familiar with the Geek for Geeks. In the Geek for Geeks, they provide two different kind of machine learning. One is the simple machine learning and the advanced machine learning projects. More than 100 machine learning projects are available. Then apart from Aman Karwal is the best person. So if any person is referring in the LinkedIn, he is provide more than 170 data science project, and also the parallelly is provide more number of machine learning projects. So these sites may help to understand what you are going to develop a machine learning project in simple way. Yeah. So this is a sample machine learning program using to decide how the user may get the amount from the insurance company. So here the data is collected from the Kaggle. So data collected related to an insurance company. So just we collect the data. After that, just we try to import a library. Just here we are trying to use two different libraries. One is Pandas, another one is Skylearn. So in this library, just we are going to use three different techniques. One is a label encoder and a train a test script. So label encoder is used to normalize the data given data set. Just I am sharing the information here. Just first thing, just we try to read the files with a help of this command. So PD is the panda. So PD dot read underscore CFC. Just we are trying to read the information from this specified the insurance.csv file. Once the information is readed, then this kind of information we get it. So just we more than 1338 rows are there. Just it contains 7 different columns. So here they are going to list out age, sex, BMI, children, smoker, region, charges. So in this scenario, we try to normalize three columns. One is sex, the data informations are redundant. Then smoker information is also redundant because the smoker may be categorized yes or no. Then third one is region. Here they are going to, the region is little bit southwest or northwest. So we try to normalize these redundant data with the help of label encoder. That's why here they are going to mention clean our data by removing duplicate values and transforming columns into numerical values to make them easier to work. Here we are going to normalize the value. That is the first column value is sex, then followed by smoker, then followed by region. Here the actual contents are replaced by numerical values. Yeah, here we are going to check it. Here the sex that should be replaced by zeros and ones, and also the smoker again it should be replaced by zeros one because both columns must having only two numerical two category values. In the region here they are going to specify three different kind of region. That's why here they are going to mention four different kind of region values 0, 1, 2, 3. So once the data is cleaned, after that we go with a train the model. For train the model, we try to divide the given data set into training and testing the data. For that purpose, here we are going to specify four different kind of variables. X a linear train, then X a linear test. So train indicate a training a data, test variable indicate the variables may be used for testing the data. So here we are going to use the method called train a test split. Is the method is used to divide the given data set into training and testing. Here we are passing entire set x len, y len, that simply copied from the data set. And the third parameter is test size. Here we are going to specify how much percentage of data we are going to put into the test. Here we are going to put it 0.3. That is sense 30% of data size we are going to fix. So that's the thing. 70% of data may be used for training. 30% of data may be used for testing. So random state is the 42 is the standard value nowadays the people are using. So random state 32 is before shuffling the data is going to generate the random numbers. So here the model is appropriate model is choosing. Here we are going to choose the regression linear regression model. So we try to adopt the linear regression model. Just we are trying to pass what kind of training data we gathered already. Just we applied. Then after that we try to predict the model. It is automatically generate the output. So here we are going to mention 1.0 is the highest level of accuracy. Then after that we are trying to finding the coefficient of each variable. So in the regression, coefficient is the strong measure is used to find the strongest relationship among the variables. So here we are going to calculate the model parameters. Then apart from, so this is the gig websites machine learning algorithm. Here they are going to provide two different kind of projects. So machine learning projects for beginners and machine learning projects for advanced. So here they are going to classify it based on different sectors. Just you go through with only one. Just we are going to they follow the step-by-step process how they are going to construct a model. So this is the informations from my side. Thank you.
Thank you, sir.
Thanks. Okay, sir. Any questions? Any queries? Shall I leave, sir?
Thank you for your insightful speech, sir. On behalf of our institution and all participants, I extend a heartfelt vote of thanks to Dr. K. Bhaskar for his invaluable contribution to our national level faculty development program on securing patent rights in India through emerging academic and research areas in the current technological landscape. Dr. Bhaskar's enlightening lecture on the basics of machine learning using Python has not only enriched our knowledge but also sparked a keen interest in the vast potential of machine learning in today's academic and technical milieu.
As we conclude today's first section, we carry with us not only the technical knowledge imparted by Dr. Bhaskar, but also the motivation to pursue our research and academic pursuits with renewed vigor and vision. His dedication to advancing the future of our field is a guiding light for the next generation of academicians and technologists. Thank you, Dr. K. Bhaskar, for sharing your expertise and experience with us. Your presence has been a cornerstone of this program's success, and we look forward to the opportunity to collaborate with you in the future.
Let us all once again express our sincere appreciation for Dr. K. Bhaskar's outstanding contribution to our learning journey.
Thank you, sir.
Thank you, Paul. Thank you, Rajesh, sir.
Thank you, sir. The next session will be started. Ma'am, please join me to share your screen.
Sir, am I audible? Shall I
yes,
share
sir.
my
Yes, sir.
screen?
Yes, sir. Share your screen. Audible.
Sir, is my screen visible now?
Yes, yes, sir. Yes, ma'am. Yes, ma'am.
Okay. Thank you for giving me this opportunity, sir.
Okay, ma'am. That's it. Welcome address will be introduced. Okay.
It is with an immense pleasure and a honor that we welcome Dr. N. Padmasini, a distinguished professor from Rajalakshmi Engineering College, Anna University, to our national level faculty development program. Today's session focused on obtaining patent rights in India using the emerging areas of academics and research in the current situation and technologies. Will be further enriched by Dr. Badmasini's expertise on the topic of object detection using machine learning in biomedical image processing.
Dr. Padmasini, with her extensive background in information and communication engineering, where she earned her PhD from the Center of Research at Anna University in December 2021, brings a wealth of knowledge and experience to today's discussion. Her academic journey also includes a master's degree in biomedical engineering from the College of Engineering, Guindy, where she graduated with first-class honors, reflecting her dedication and prowess in her field.
Over the past nearly 15 years at Rajalakshmi Engineering College, Dr. Padmasini has made significant contribution to the field of image processing with a special focus on ophthalmology, demonstrating a profound commitment to advancing healthcare through technology. Her research has been recognized and cited extensively in the academic community, as evidenced by her impressive station matrices and portfolio of 16 journal articles.
As we delve into the intricacies of machine learning and its application in the biomedical image processing, we are confident that Dr. Padmasini's insight will provide invaluable knowledge and inspire innovative approach among our faculty members. Her dedication to her field and her achievements in research are a testament to the impact that focused academic inquiry can have on real-world applications, especially in the critical area of healthcare.
Please join me in extending a warm welcome to Dr. N. Padmasini and let us embark on this enlightening journey together, exploring the frontiers of machine learning and its transformative potential in biomedical image processing. Thank you.
Thank you, madam. Thank you for giving a wonderful introduction. Now we'll go into the topic, object detection using machine learning for biomedical image processing. Hope I am audible to everyone.
Yes, ma'am. Yes, ma'am.
Yes,
Ma'am, please,
okay.
presentation mode, ma'am. Only the small screen only show.
It's in the presentation mode only, sir. It's in the
Oh,
presentation.
no, yes, ma'am. Now, correct. Or otherwise, you will press the F5 press button.
Now is it in the presentation mode, sir?
Yes, ma'am. Yes, ma'am. We will continue, ma'am. No problem.
Yeah. Yes. Today's I will be discussing about object detection using machine learning for biomedical image processing. So my research, as mentioned by madam, it's on ophthalmology. So we will see some case studies also. Before going to the case studies, I will brief you about some of the medical images and how it is used. Machine learning is used in processing these medical images. We will go one by one. So these are some of the medical images as you see in the screen. So these important medical images are brain MRI, brain CT. After this COVID brain, CT images, lung CT images are more popular and more research work are going in lung CT. Of course, retinal images, all of us might have visited an ophthalmologist for one or more reason, like short sight, long sight, and if you have an elderly person at home, they might have gone for some form of scanning. So as you see here, it's a retinal fundus image and retinal OCT image. OCT is optical coherence tomography image. That also you can see over here. So how to process these images, how machine learning helps me in processing these images, we will see one by one. So here, whenever we speak about the images is in the form of matrix numerical values. So it is stored in the form of numbers. So at the back end, if I see the image, we should recognize as numbers. Now, what are these numbers? These numbers are the pixel values. So if I take this image, brain MRI or brain CT, the scenario behind this image is a matrix of numbers. So all the detectors which we use in the present scenario are digital detectors, which makes use of the matrices for storing the intensity values. So this matrix gives you the intensity values which is stored for each and every image. Whenever I want to recognize an object, there should be some change in the intensity value. Now, what is this change in the intensity value which helps me to recognize that object? So here I have given the highlighted information in yellow as 255. So all of us know as a grayscale image varies between 0 to 255. That means the pixel value takes a value 0 if it is black and 255 if it is white. Now, suppose I am having a black region in the middle, which is surrounded by a white region. You can see the pixel values as having 255 in the middle 0. Now, if I am able to detect this 255 pixel values, which I call it as edge, then my object which is inside a black object can be recognized easily. So that is the key concept why we go for edge detection or pixel. So edges are significant local changes in the intensity of an image. So to be more clear and explain about how the object is being detected. Whenever we speak of a medical object, some form of information which is hidden. See here in this figure, you do have a brain tumor image which is shown in red in color. So this red color gives me the information in the picture, an abnormal brain image. So for that, how can I?
Excuse me, ma'am.
Yes, sir.
First,
Yes, sir.
slide only it is show, ma'am. Remaining second slide and not.
Remains, so I'll give you the PDF, sir. Why it is not? Again, I'll
Scroll your PDF. Ma'am.
Yeah, I am scrolling only. I am seeing that and only telling. 1 second, sir. I will see the.
Okay, ma'am. I will wait.
Where is it now visible?
Yes, ma'am. Yes, ma'am. Visible.
You say I am scrolling. Is it visible? Object detection. That slide.
Yes, ma'am.
Object detection. Is it visible?
Visible.
Yes.
Everything visible.
Okay, sir. So object detection. As I told, so you might have lost my previous slide also. So this is the pixel matrix which I was discussing. So this 255 represents the white color and 0 represent the black color. If I am able to detect this 255, then the black color object which is inside this white region can be detected. So for that, what we are going to do? So this traditional object detection models can be mainly divided into 3 stages. One is informative region selection. The second one is feature extraction. And the third one is classification. So this is the brain image, which is a red in color in the region. This region I want to analyze. So what I have to do, first of all, select this region. Then I have to extract the feature and go for classification. That is the basic information or basic model, any basic model which I want to give the information about the image automatically. I have to do these steps. So my objective is not only to classify the object into predefined categories, but also draw the bounding boxes around them, pinpointing their exact locations in the visual data. So your object detection has two types. One is a salient object detection and the next one is generic object detection. What is salient object detection? So it is local contrast segmentation. What is local contrast segmentation? I have an image. I want to segment that image. Now, I do some form of edge detection in the image in order to highlight the region of importance. Then I go for features extraction. So in the generic object detection, which is now you might have seen in the deep learning things, suppose I have a scene of so many people walking through a street and a car, a truck is going. I want to identify who are the persons, who are the van, or whether it is a truck. I do have a bounding box. That's called a generic object detection bounding box regression. That is famous, or it is popular in the nowadays deep learning scenario. So what we do here in the traditional object method is that, as I told, it's the selection of region, extraction of features, and classification. Now, for the clear information about the object, first step is to do image segmentation. So segmentation divides an image into its constituent regions. And the segmentation of images is a very difficult task. It's not very easy if you go for automated segmentation. Even automated segmentation is still under research. You can do more research on medical image automated segmentation. And segmentation allows to extract the object in the images, and it is an unsupervised learning. If it is a supervised learning, I can give the data as Sir told in the previous session. The supervised training, I do have a labeled data I can give, but the segmentation, if we go for automated segmentation, it becomes an unsupervised learning one. So which is a difficult one. It has to match some form of template matching. Then you have to, first it has to be a supervised learning. Then we have to go for unsupervised learning. So traditionally, how the segmentation algorithms work, what are the traditional segmentation algorithms is, in the first generation, we go about thresholding, region growing, edge-based methods. In the second generation, we have deformable clustering, watershed segmentation, Markov random fields. Now, with the third generation, as we make use of machine learning techniques, we make use of classifier, graph-guided one, atlas-guided, and hybrid approaches. In the first generation one, thresholding or region growing, it's a very simple one. We will discuss each and everything in the next coming slides. So in the image segmentation, the method of segmentation is, one is a similarity based. The next one is discontinuity based. What is similarity based? I take a region, wherever I find the similar pixels, I go on growing that pixels, giving a threshold value. Suppose I need a region between 50 to 60. That means the pixel value is 50 to 60. My threshold value is 50 to 60. I take that region that I give the pixel, pick up the pixel values between 50 to 60 and give me the output. So that is similarity based. What is edge based? Edge based is that wherever there is intensity change in the matrix, I have to pick up that intensity change and give us output. That is edge based. So we have thresholding, we have region based, we have split and merge algorithm, we do have fast scanning algorithm, we do have DP clustering algorithm, and in the discontinued based, it is edge-based algorithm. Edge-based algorithm is, of course, easier one. We detect the edge, then we take the innermost region and we analyze. Okay. So this one, edge detection. Edge detection is a fundamental image processing operation used in computer vision solutions. So the goal of edge detection algorithm is to find the most relevant edges in the image or scene. That the edges will provide a meaningful lines. If it is a boundary means, there definitely there will be an intensity change. Now, how I am going to pick up that intensity change, that is my task. Then I go for feature extraction and classification. And the edge detection, for detecting the edge, we do have certain operators, that is a gradient-based operators or Gaussian-based operators. In the gradient-based operators, we do have Sobel operator, Previtt operator, and Robert operator. In the Gaussian-based, we do have Canny, Laplacian. What are these operators? I'll tell you. Especially this Laplacian of Gaussian operator will help me in identification of points. If there is a point in the image, it helps me to identify. So each and every operator has its own matrix. So you can see here a Sobel operator. A Sobel operator matrix takes this form -1, 0, 1, -2, 0, 2, -1, 0, 1. And this one is in the y direction. Now, what we do is that we convolve the convolution is there any questions?
Ma'am, please, ma'am.
So Sobel operator, so we do have this in the x direction, and with this we have in the y direction. What I am going to do, convolve this operator with that of my image. This operator will help me to fetch the edges of the image, the Previtt operator also. So convolution, whenever we speak now in the machine learning or deep learning, convolution plays an important role. Why convolution? Whenever we do have an operator like edge detection operator, we convolve with that of my image matrix. This helps me to identify the edges. Once my edges are identified and my image is segmented, the region is being segmented, I can easily analyze. So the first step, everywhere, wherever you go, it is edge operation. So here we do have Sobel, Previtt, Laplacian of Gaussian, a very, very good operator in fetching the edges. So here what is happening is Gaussian is, here you have a Gaussian function 1/√2 pi sigma squared exponential minus of x squared plus y squared divided by 2 sigma squared. And LOG, what we do is Laplacian. Laplacian means it is a second order derivative. So second order derivative is dou squared by dou x squared. What we do, we apply over this g of x comma y, and we get the Laplacian of Gaussian of my image. And the Canny operator, it does not have any matrix, but it is a powerful, excellent operator which helps me in getting the edge points by making use of non-maximal suppression. So it makes use of two thresholds. Within the thresholds, if my pixel value lies, it will obtain all these pixels and process it and gives me the edge. That is the simplified version of Canny operator. Of course, what is done behind the Canny operator is somewhat complex only. So to give a glimpse about the edge operators, I touched this one. And you can see over here the comparison of edge detection operators. Here you can see the Canny operator detected my edge very well. So this is a CT emphysema image which I made use of Sobel operator. Then I made use of canny operator too. Canny operator helps me to fetch it small structures. You can see the very small structures over here. So we conclude that the canny is a best edge detection operator, but sometimes it may cause over segmentation also, picking up very small points which are very much unnecessary. So noisy points may also occur. But the advantage of Sobel image is that it will clearly pick up the well-defined regions. But the small regions, sometimes it may pick up, but sometimes it may be left out. That is the disadvantage of Sobel operator. So to go more advanced, this is based on edge detection. The next one is based on region blowing or clustering. Here you see a brain MRI image. Now, by making use of, I want to segment this as middle region. We have cerebrospinal fluid region. That region I want to segment. Here you see in the second image a white region, that is my cerebrospinal fluid region. How to detect that region? By making use of region growing algorithm. What we give is that we choose this region, center region, and we give the threshold value as this is a black pixel. So I grow on the region by making a seed value of 0, giving a seed point as 0. I build the region. So my center region is being segmented over here. So this is our region or clustering technique, which is going to be applied. So cluster, if it is 4, it is cluster 1 applied, cluster value k is equivalent to 4, cluster value k is equivalent to 5. That means I am taking 5 seed points. Here I am taking 6 seed points. I am taking 8 seed points. I am going the cluster. So this is how the segmentation can be done region based also. So the next one is that the feature extraction, color, texture. So I have segmented the image. Now these are the images I have segmented. Now I want to go for extracting the useful information. For that, I have to analyze what are the features present in that area. So analyzing the features, what is the shape of the segmented region? What is the color of the segmented region? What is the texture of the segmented region? All these are the features. So feature extraction, features are given color, texture, shape. Shift is a very important feature in the nowadays present scenario. Scale invariant feature transform. All the medical images, if we take, it will not have the, if I am taking a CT, my CT, though it is normal, if I take the normal CT of another person, I cannot say it is having the same scale and size. For that, if I take scale invariant feature transform, it will be good. So it is invariance to image, scale, and rotation. Well, while coming to the case study, I'll tell you why this shift features are very much important. Then we go for surf features, speeded up robust features. Then we have statistical features, mean, entropy, skew, kurtosis, etc. Then we have structural features, whether it is a circle or whether it is having a rectangular structure. Then we have a morphological feature, whether it is having a dilated region or whether it is having a wide region, narrow region, in a black and white image, morphological structures. Then run length. Run length is also how the pixels is varying. If the pixel is coming in a pair twice or thrice, how much run the pixel is appearing. All these features contribute to the structure of the element which we have segmented over here. So the important image feature is texture. So texture is an important spatial property that can be used in region segmentation as well as description. Here you can see in the screen how the GLCM features. The left side is my image matrix. So you can see this is having 1, 1 in pair. GLCM is a gray level co-occurrence matrix. That means it is occurring in pair. So how many times this one? So here you see in the x-axis 1, y-axis 1. So this 1 will be taken into account. Now it will see this image where 1 is lying. So here it is having 1, this 1 time. Nowhere in the image we see 1. So 2, 3, how many times it is occurring? 2 in the y direction, 3 in the x direction. Now I can see it is occurring 3 times in my image. This GLCM matrix helps me to understand how my gray level is there in the image. If I calculate the statistical features like entropy, energy, it will give me more information. Not only this image feature, most important feature is texture. Texture is how the appearance, whether it is having a rugged appearance, whether it is having coarse appearance, whether it is having smooth appearance, all these can be decided using the GLCM features. Then the scale invariant feature transform, that is also a very important features which helps me to get the multiple transformation, whether it is it is variant to scale, orientation, or any affine light distortion also. My feature scale invariant features will help me. And the oriented fast and rotated brief is a feature detection description algorithm in computer vision that combines the speed of fast key point detector and the accuracy of brief descriptor. This is also gaining more importance nowadays in the present medical scenario. So why this feature extraction is useful? It helps me to reduce the number of resources without losing any important or relevant information. Feature extraction helps me to reduce the amount of redundant data which is present. So here, the next one is a feature selection. Now we have extracted the features. What are the entropy, shape, color, texture, all these features are being extracted. The next one is feature selection. Why feature selection is important? I have to see which features are very much correlating with that of my output. So here I have taken a heat map. We call it as correlation heat map for the GLCM features. So I have taken the GLCM features like contrast, correlation, homogeneity, entropy, energy, and I have given the target. So if I take imagine I'm having 2 types of image. One is a image which is having abnormal CT. Another one is a normal CT. I'm taking contrast, correlation, homogeneity, entropy, energy for both these CTs, and finally I'm giving a 1 column of value. If it is 1, it is normal. If it is 0, it is abnormal. I am giving the value. Now I am taking all these, I am plotting a heat map. This heat map can be plotted using your Python or your MATLAB. As I have extensively worked in MATLAB, this is I have obtained from MATLAB. So these feature selection, I have rounded 0.8. That means it is having 80% correlation. What I am telling, this contrast with respect to my target, it is 80% correlating. Correlation, that is I am taking correlation as one of the feature, that is 70% correlating. Homogeneity, it is not matching. You see, the value is minus 0.6. What does it mean? My values, if it is homogeneous, means my target value is not coinciding with that of normal or abnormal. Even my normal regions also have, normal images also have homogenic regions, and my abnormal images also have homogenic regions. So for that, it is not matching. So here I do have a heat map which helps me to identify which features are coinciding with that of my target value, or which I am going to predict. So feature selection helps me to predict the important features which are contributing to my end value. So what is contribution? So if it helps me to judge my output, whether it is normal or output, abnormal, this heat map will be very much useful. So after this feature extraction, feature selection is very, very important. So moreover, feature selection, if I give, suppose I am having 20 of features. I'm selecting and giving 10 features. Now my machine will be feeling very much easier to classify the object. On the other hand, if it is having more number of features, sometimes it may give the good result, sometimes it may take a lot of time, and the accuracy also decreases. So this feature selection is a very, very important point. Once I obtain the features, extracted the features, I have to see which features are correlating. Manually, I can inspect, but I am having thousands of data. How can I go for the inspection? There I can plot a heat map that will help me for identification of features. So this way, this feature selection is very much critical and important in any of the research work. So the next one is, I am having a machine learning and a deep learning for object recognition. So what I have detected my edge, I have extracted the features, I have selected with the correlating features. Where can I go? Whether what is the algorithm I can use? I can go for machine learning algorithm, or I can go for deep learning algorithm. If I have a good hardware, so I am playing on millions of data. So I should have a good GPU, good hardware, and I have a lots of data, means I can go for deep learning algorithm. If I am not having, only I am having restricted data, and I'm having a original Windows with the operating system, 10 operating system, normal thing, I can go only for a machine learning algorithm. The main advantage of deep learning is that you need not give the features. It will get the features on its own, and it will identify. See here, there is a excuse me. There is a deep learning workflow. I have trained a cat, a dog, a parrot. I have it has taken the features. I need not extract the features from these images. It will extract, but you may ask the question whether we can extract the feature and give. Yes, of course, you can extract the features and also give to the machine, and it will help you to identify whether it is a cat. My test data here is cat. Now it is going to identify it is a cat very much clearly. Okay. This way it will be helpful for me to give the deep learning. So deep learning, it deals with a large amount of data if it is in my hand. Now the evolution of this is the how my in the present scenario all are talking about computer vision, evolution of deep learning, image classification. Now here our object detection comes over here, which is shown in red box. So this object detection helps me to identify what is the hidden object which is present in my image. And the feature extraction, convolution neural network, how it emerged. In 1999, Swift features came into picture. Then Viola and Jones, this is a famous machine learning for machine learning classification. This was giving very much good accuracy. And the bag of words in the natural language processing for text analytics, bag of words in 2003, it was gaining more popularity. In 2005, hog feature, histogram of gradients gained more importance. Then it emerged. Now you can see AlexNet, the deep learning network, came in 2012, the red one marked. Then after that, all the deep learning neural network like ResNet, DenseNet, now MaskRCNN, is YOLO. All these networks are very much common. So what is RCNN? The last one which helps me to identify the object. Why I have not chosen the other networks is that RCNN helps me to identify and classify the regions. It will automatically segment and it will also give me, this is the man. It will label and give me the detail. It's a man, it's a car, it is a mobile, all these things it will give a segment and give me the information. RCNN, regional based convolution neural network. Now, machine learning techniques, what are the machine learning techniques which helps me to identify HOG along with the SVM? It's a very good classification and it will give more good accuracy, histogram of gradients with the feature extraction. Back of word models, this will give more accuracy when you're making use of text. It is also, of course, used in some of the medical images. And the Weiler-Jones algorithm, it helps me to recognize a variety of objects. And the HOG with an SVM machine learning model, which will be very much helpful for me. And this SIFT features will help me in image registration. You can see in the side 2 Eiffel Towers. There's a picture which has been taken in a different view. So here, how the points are being correlated using SIFT, scale invariant feature transform, and helps in the identification or object. So I am taking these two objects and giving it to a machine learning algorithm. I have to take the SIFT features to identify it is a Eiffel Tower. So that's a key behind the SIFT features. And as I told, hog histogram of gradients. Gradient means it is the orientation of the edge. In what angle my edge is oriented? How can I take the angle? Very simple. Tan inverse of gy by gx will give me the angle. And root of gy squared plus gx squared will give me the magnitude. Now I am taking the histogram of gradients and I am taking the SVM classifier to identify. What is the demerit of HOG is that it will take long time to recognize an object since it employs sliding window approach to extract features. Whereas the SIFT algorithm, it is extremely slow because I told it will be correlating point by point feature. So it is very slow. And the Weiler-Jones algorithm, it is the demerit is that it can be used for many applications, but it is limited to binary classification. Binary classification means I can say whether yes, present or no. I cannot go for multi-class classification. Like consider there is a CT image with less severity, medium severity, high severity. How can I give? I cannot go for Weiler-Jones detector. So how my machine learning is used for object detection? Here you can see the features are extracted, the feature vectors are selected and given as input to the machine learning algorithm. It is being trained, and the best classifier is used for predicting the destiny. This is the key behind the machine learning. Now we'll go by one the case studies which is done by us, and this case study involves identification of structural changes of diabetic macular edema. So what is diabetic macular edema? You might have heard about diabetic retinopathy, where your retina gets affected due to diabetes. Why? Retina is full of blood vessels. You can see more blood vessels in your retina, and your blood vessels become thicker and thicker if you are having diabetes. If your sugar level is increasing, your blood vessels will be thicker and thicker. At that time, what happens is that you will get the changes in the retina. See here, there is a normal retinal layer. Of course, your retina is a 10-layer structure, and all these layers are imaged using optical coherence tomography imaging over here. There is a normal structure over here. This is the initial stage diabetic macular edema. You can see some form of spots over here. when it is advances, it has a blob regions like which is called cystoid. And when it comes to the end, it is having serous macular detachment. And there are so many structural changes due to time constraint. I try to limit my presentation. So this identification of these structural changes is a problem in using deep learning. When you may ask me whether I can go for machine learning. First of all, we tried with the machine learning. What we did is that we segmented the edema filled region. We segmented the regions by making use of level set method of segmentation. We extracted the features of histogram, run length, and TLCM, and we determined whether it is a clinically significant one or whether it is having mild, moderate, or severe significance. We gave these features to a random forest classifier. Of course, it was very well classifying with an accuracy of 96.1 and 98 if my trees and splits were used. And when I gave to support vector machine classifier, again also it gave more than 96% accuracy. So you can see over here, these SVM made use of quadratic, linear, and Gaussian. In this research work, we made use of quadratic classification. This quadratic function for the kernel function for classification, and we obtained good accuracy. But when it was asked to identify what is the structural change, tell me. So I told you about all these structural changes. So whether it is a initial stage or whether it is a start stage, but this machine classifier was not able to identify. See here, the accuracy is only 17.1%, and here the accuracy is 25% in identifying the object such as SMD or cystoid. So we gave 6 classes of images and we asked to identify, it was not able to identify. What does it mean? More features are required for machine learning. So machine learning, though we obtained the hog features, shift features, and we were able to increase our accuracy to about 70%, not more than 70% increase. Now what we did, we went for a deep learning algorithm called ResNet 50 architecture, where it helps me in identifying the object very much correctly. So here you can see the rounded one. The accuracy is 97.5%. Whenever we are taking the accuracy, we should not see the accuracy alone. We have to see the receiver operating characters. That's what ROC. ROC is receiver operating characters. I have taken, and we have seen all the receiver operating characters crossed 90, more than 90. That is the beautiful, or why this algorithm is working very much conveniently in identifying all these structural changes. Now, what is happening inside the deep neural network? What I told, the extraction of features is important. What features I have to extract? I have to extract the edge. I have to see the orientation. I have to see. So what is inside this ResNet? The ResNet is making use of convolution layer, batch normalization, ReLU, max pool. If I want to speak about this deep learning, this itself takes one session. So I'm just giving a glimpse what is the work done, what the accuracy we got, how we got good accuracy. Layer by layer, it is analyzing and it is giving the information. You can see over the last image, the averaging pool, it is taking off the red regions. Wherever there is a cystoid, it is taking off the red regions and it is going to classify. So you can see the sample tested outputs over here. So it is giving correctly. It is a cystoid plus SMD is present. This one is a normal image present. This one is a exudates present, and this is cystoid plus IRF, which is being present. So the next one is that I want to see the segmented region of the image. Which region contributed to my segmentation? For that, ResNet alone did not work well. So for that, we took mask RCNN. What is mask RCNN is that it will give the segmentation mask depending upon the problem if we are training with that of the segmentation mask. So here the YOLO can also be used, but what is the difference between YOLO and mask RCNN is that it provides a mask RCNN additionally provides instant segmentation with the mask. But YOLO is not able to produce. So this is semantic segmentation and this is instant segmentation which helps me more information about the persons. So your mask RCNN architecture is like this. It makes use of a ResNet along with the mask and the feature propagation network, which helps me to analyze the proposals of the feature and give me the output. See here, all these regions are segmented very much clearly and giving me the label. First of all, it gave me the label alone. Now it is able to give me the segmented regions as well as the label. So it's a mask RCNN along with the inception ResNet V2 helps me to identify which regions contributed more for my identification of that regions. So it's a very, very important, it's a PhD work which helps me to identify. We tried with the trial and error, we brought about how these classifiers worked out. And the next case study is a fundus image. This is also a retina image, a diabetic retinopathy. There are regions called soft exudates, hemorrhages, microaneurysms. How these regions can be effectively detected is by making use of a net called efficient UNet architecture, which is being modified efficient UNet architecture, which helps me to identify all these regions. You can see over here how the yellow represents hemorrhage region, that is a gush of blood flow. Red spots, which is microaneurysm, it's the initial stage 1. Light blue, which represents the exudates. All these can be seen clearly in this picture. So this is a proposed network, how it helps me in identification of the region, and our proposed efficient net gave an accuracy of 99.6% with a sensitivity of 98.13%. And what are the challenges in real-time object detection like this is that occlusion, scale variation and cluttered environments. What is occlusion? If there is a noisy element which is occluding my image, I want to get a tumor region, it is full of noisy region, that's a challenge over there. Then I have to remove that noise, then only I have to go. If there is a scale variation, suppose I am imaging my eyes, I am wearing spectacles. My image, retina image will not be same as a person who is not wearing spectacles. So there is a scale variation. There will be deformations in the image, it will be angularly deformed. All these things will give me variations. So I have to first correct that one. Then cluttered environments where if I am going to image one region, if the out of focus region is also coming into picture, which is similar to that my region of interest, that is also a challenge. How can I come across? These are the challenges in the real-time scenario. And for object detection, you can go for one more technique called registration also. That work also which is done by us, fundus image and OCT image, which is being this first one, red is a fundus image, and the next one, the second one is a peripapillary OCT image. Both these images, when they are given registration, that means fused together, it will give me more information. You can see over here how it is registered. So the algorithm goes like this. So the image registration, fusion, and by making use of k-means clustering, how it is giving me the class, how the classifier is giving me the output. So these are some of the case studies. As my topic given to me is object detection with respect to medical images. So to give a nutshell about my presentation, I started about what is segmentation, what is edge detection, what is the importance of feature selection and feature extraction. Then we selected, then we gave to various classifiers, machine learning classifiers, where my machine learning classifiers can be used, where it failed, then why we went for deep learning. Now in the current scenario, YOLO, Med-YOLO, and the mask RCNN, these are playing important role. So my input to the freshers who are going to do research is that you do a network, you take a network on your node, you design your network. Do not, what we people do is that we take an existing network, we give our data, train our data, we try to get the output. Now, if you are designing a network on your own for your PhD work and you are implementing for a hospital set of data, it will be very, very useful and you will definitely get a publication out of your work. That's the key point I want to tell. Rather than going for the existing networks and giving our images and training and testing, you can design your own network. Thank you for your patient listening. If you have any doubts, you can ask me.
Thank you, ma'am.
Yes.
Thank you for your insightful speech. On behalf of SKP Engineering College, I extend our deepest gratitude to Dr. N. Padmasini of her invaluable contribution to our national level faculty development program. Dr. Padmasini lecture on object detection using machine learning in biomedical image processing has not only enhanced our understanding of this critical field but also illuminated the path for future research and application in healthcare technology. As we conclude today's session, we carry with us the valuable lessons learned and the inspiration to pursue excellence in our respective fields. Dr. Padmasini's contribution to our program has been instrumental in broadening our understanding and sparking a passion for innovation among our participants. Thank you, Dr. N. Padmasini, for sharing your expertise with us for a beacon of knowledge and inspiration. We look forward to the opportunity to collaborate with you again in the future. Thank you, ma'am.
Thank you, madam. Thank you for giving me the opportunity. I would like to thank our management. I would also like to thank Jobin sir, because actually he was only for this session, as due to emergency, he was not able to join the session. So he handed over me the session. Thank you very much. I would like to thank Professor Raju sir also for giving me this wonderful opportunity. Thank you, participant. You are welcome. Anytime you can ask me your doubts. You can get my
On
email
WhatsApp.
ID from sir also. Thank
Thank
you,
you,
sir.
ma'am.
Thank you, sir.
Suja Alex, ma'am, you will share your screen, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, I'm sorry.
We are honored and delighted to welcome Mrs. Suja A. Alex to our national level faculty development program, where she will be shedding light on the crucial topic of text analytic using machine learning. Mrs. Alex's remarkable journey in the field of computer science and her extensive research in machine learning and deep learning make her the perfect guide for today's session, aimed at understanding the intricate relationship between patent rights in India and the emerging academic and research areas in our current technological landscape.
Mrs. Alex embarked on her illustrious academic journey with a BTech in Information Technology from the Cape Institute of Technology, Anna University, Chennai, graduating with distinction in 2006. Her academic excellence continued with an MA degree in Computer Science and Engineering from Aruna Engineering College, Anna University, Chennai in 2008, where she was recognized as a university rank holder.
In pursuit of deeper knowledge, Ms. Alex Alex completed her PhD degree in the area of imbalanced data classification under the esteemed guidance of Dr. J. Jesu Vedanahi at Anna University, Chennai. Since 2008, Miss Alex has been nurturing minds as an assistant professor at St. Xavier's Catholic College of Engineering, Autonomous, Nagarkoil, where her passion for teaching and research has flourished for 15 years.
Mrs. Alex's contribution to the academic community are notable, including her role as an editor for the Future Generation Computer System Journal with X-Level starting January 2024, and her recognition as an outstanding reviewer by FDCS in 2023. Her dedication to excellence in further evidence by numerous awards and achievements, including Excellent Publication Award and the prestigious First Faculty Award for her exceptional results in the courage, big data analytics.
As a member of several professional societies and an educational consultant, Ms. Alex continues to influence the field of machine learning, deep learning, generative AI, and imbalanced data classification. Her role as reviewer for esteemed journals and conferences underscores her commitment to advancing knowledge and fostering innovation in computer science and engineering.
Today, as we delve into the fascinating world of text analytics and machine learning, we are privileged to have Mrs. Alex guide us through the complexities and potential of this emerging field. Her expertise and insights promise to enlighten and inspire all participants, fostering a deeper understanding and appreciation of the transformative power of machine learning in biomedical image processing and beyond. Please join me in extending a warm and hearty welcome to Mrs. Suja A. Alex. We eagerly anticipate the knowledge and inspiration she will share with us today.
Thank you. Thank you for the warm welcome. Shall I start this session?
Yes, ma'am, you will start.
Okay. First of all, I am Dr. Suja Alex. They said about a lot, right? Okay. My session topic is text analytics using machine learning. Okay, this session I am going to cover the basics about machine learning. Then one of the basic technique called base classification. Then followed by the text analytics, where I have chosen again text classification approach. Then how this base approach can be applied over text classification. First, what is machine learning? So machine learning is a general term. Nowadays, it's very popular. Many students and many researchers are moving towards this machine learning domain to do their research works. So, and apart from the machine learning, now the trend is changed, like AI, it is now very booming. So when compared to AI, this machine learning is just a part. So what is machine learning? So traditionally, we are having a habit of doing a program. So in the program, normally what we do is we do some computations and finally we get the output. That's all. And we won't give any kind of intelligence to the normal program, normal C or Java program. But in the case of machine learning, they have to provide some kind of intelligence to the ordinary program. So the intelligence can be given with the help of some various algorithms, or what will be the expected output. So we are telling the program that I want this kind of output, or I want to label. If this condition is satisfied, provide this label. So I'm teaching or giving training to my program that to do React if you get this type of input. Or if the input is different, then show the output like this. So I am giving a lot of training to my machine learning, to my program. Finally, I'm making my program to become a more intelligent program. So that is the meaning of machine learning. So the general definition is it's a study, design, and development of algorithms that gives the computers capability to learn without being explicitly programmed. So next, types of machine learning. So basically, the machine learning is classified into three categories: supervised learning, unsupervised learning, and reinforcement learning. So among these three types of machine learning. All three are most popularly used by the researchers in many research works. I usually prefer this the supervised and unsupervised. I have not much used in reinforcement learning. So what is the supervised learning is, it's actually what I said now. That is, we are providing a training to that program, ordinary program. I am giving it training and I am teaching that this is the output or expected output I want. So accordingly, I'm training my program. That's called as a supervised learning. So where the expected output or the label, that will be given during the training process. That is the meaning of supervised learning. It's like how that in the classroom, teachers and students are there, the same thing. Students are supervised by the staff or the faculty. So similarly here, all the data and process, everything is handled with the help of a training process or a learning process. So training is a part of this uh, type of technique. And here the input, we have to provide the expected output, what we want at output. That's what we call it as labels. So during the training process, the labels will be given along with the training process. And based on the output, we can also fine tune the results. That is the next thing, fine tuning of results. And some of the common algorithms are classification algorithms, the task classification purpose and regression task, where we can use this supervised learning approaches. The second category is unsupervised learning. So in this unsupervised learning, it's actually the unsupervised learning is how to say, there is no need of this training data, or you can say that no need of that labels. Label is not necessary. The actual raw data can be given as the input to the model. Then the model can work real time on the data and providing the output. There is no procedure of giving the training the model earlier. But in the case of supervised learning, we have to train first, then we can go for the testing process. But here in the supervised case, there is no need of using the training. Directly we can have it directly we can process the data by get the output. And there is no need of that label or the target value. We are not providing anything to the algorithm. Directly we are getting that the process, that is, we are getting that the process structure or the, how the data is, that is how the training data is clustered. So the internal architecture or the pattern we can easily get with the help of this unsupervised learning approach. So the most popular techniques are, that is dimensionality reduction, feature selection, then a clustering. So those approaches are the examples of example techniques of unsupervised learning. The third category is the reinforcement learning. So this reinforcement learning is totally different than the supervised and unsupervised learning, because here also we are providing the data to that network or to the model. So we are getting some output. We are not training the model with the help of a sample output. We are not providing an expected output, or label won't be given to the model. So directly we are getting the output. Then based on the output, we are finding that error or the reward. We call it as a reward. So that reward will be given to the will be again given to the input as a feedback. So the reward may be a positive or it may be a negative. So based on this reward values, the input is again given to the algorithm, and again the network will be of training further, like an iterative process, and finally we get the fine-tuned result. This is fully based on the environmental effects or the rewards get from the outside. It won't depends on the internal model strength. It fully depends on the external environment parameters. Okay, next, just I move on to this Bayes classification. So already I told that the classification is an example of a supervised approach. So in the supervised approach, we have two process, training and testing process. So in the training process, we have to provide the exact data along with that. What are the input variables I have and what is the output? Everything I have to given in the training process. Then the model will be trained with that training data. Then after we are getting the model, we can test with the sample or the testing data. That is the case for the supervised learning. So there are many algorithms in classification purpose called support vector machine, logistic regression. So there are so many approaches to perform this supervised learning. So I have this session, I am going to explain you the Bayes classification technique, how it is to work, the basic principles, and with an example, I will tell you. The Bayesian way of data analysis. Actually, this Bayesian classification is fully depends on the Bayesian statistics. That is, it is fully based on the few concepts like that uncertainty, probability, that is we call it a hypothesis. So these are the basic terms used in statistics, right? So those basic small concepts are used here in Bayesian classification approach. So here we should be familiar with the basic mathematical concept like conditional probability. First, what is the meaning of probability? Conditional probability. Then the meaning of hypothesis. So these are all the basic terms in statistics. So once we thorough with those basic topics, then we can easily move on into this Bayesian data classification approach. So here it is fully based on that Bayes theorem. So mathematically, we all learned the Bayes algorithm in the earlier days. So those same algorithm, Bayes algorithm is a core part of this Bayesian data classification approach. So here it simply calculates the probability of a hypothesis. So hypothesis means we can create, that is, we can have a label that for a particular set of input values, I can say that it is yes, that is one hypothesis. For another set of input values, I may set that hypothesis no. There can be of two things, maybe true or false, like yes or no. So this is called a hypothesis. So when we have two or three hypotheses, we may not stick on the one. So out of the three, one may be the best hypothesis. So how to find the best hypothesis, that is the toughest point. So this Bayesian data classification is fully based on this classification of this hypothesis. For example, the data, if you have a good or bad or true or false or yes or no, those type of hypotheses may be there in the data. So we will calculate the probability. So probability for the yes hypothesis and probability for the no hypothesis. Then we have to check that value which is the highest one. So those highest probability hypothesis will be assigned a label for the new data. So this is the basic, the core concept behind this Bayesian data classification. So here we need two things. We need the prior distribution of the data and also the actual input features or the input set of vectors or input variables we are going to call as the data. So prior data distribution and data. So both are the input to this Bayesian data classification. So in the Bayesian model, this is the basic concept is called as Bayesian modeling. Actually, here we can represent any, normally we can data set means we know that it's like a tabular way of representation, right? This is a CSV file. So we can see that every column as a feature or attribute and every row we call it as a record. So like that, the CSV file, we have so many records or values may be there. So in the case of Bayesian modeling, the same CSV file or the structured file can be represented in the form of a graph. So here the graph is a probabilistic graphical model, or simply we can say it's like a statistical model. There is we have various circles here. It denotes various nodes, and these lines denotes that edges. That is in the graph. So a set of nodes and set of edges. That is actually a directed acyclic graph. So this graph is the core part of this Bayesian data classification. So for any tabular data, we can easily convert into this Bayesian graph. This is called as a Bayesian graph. So this graph easily shows that for this A, B, C nodes, this B and C are the children to this parent node A. So this is what the graph meaning. So for this node B, D is a child. So accordingly, so all the nodes by the arrow mark direction, we can easily identify which is the parent node, which is a child node. We can easily identify this. So all child node depends on the values of the parent node. That is the main thing, the conditional dependence. So here A, from A to B, we have a link. The meaning is B depends on A. It's a conditional probability. B depends on A. So this so each edge denotes the conditional probability or the conditional dependency between two nodes. And these Bayesian networks have a different names. It's called as Bayes net, belief network, Bayesian model, probabilistic graphical model. So there are various names are there to represent the same thing. Now we can move on to this Bayes theorem. So Bayes theorem, it was invented in the 17th century and it's very old algorithm, Bayes theorem, and it was invented by Thomas Bayes. And this is the same graphical representation I said. So for example, A, B, C, D are the input variables. And this Bayesian graph denotes the how all the variables are connected and the dependency between them. It is shown in this Bayesian graph. So now this Bayes theorem, is actually a probability of, there is probability of C given F equal to probability of F given C into probability of C divided by probability of F. So here this C means actually the what type of class. It said that the hypothesis. So here the class is called as the class attribute is called as hypothesis deciding attribute. So there is this class C, maybe yes or C, maybe no. They may have, for example, in the case of binary classification, we have two values, yes or no, true or false. We have two values only, or 1 or 0. So here, so the C denotes the class values, and this F denotes, the capital F denotes that various features or the various input attributes, input variables we are taking. That is F1, F2, F3. F1 is the first variable, F2 is second variable, F3 is third variable, up to n number of variables. So in the set of variables represented here, F. So the label, that is, for example, probability of C equal to either yes or no, we can calculate. For the case of binary classification, we calculate both what will happen for the yes case and what will happen for the no case, given the set of all the input variables. That is called as a F. So from the input variables, we are going to find the probability of the class label yes. Similarly, we are going to find the probability of the class label no from all the input variables. So this P of C given F is called as a posterior probability distribution. So this is a posterior. The posterior in the sense we may not know what will happen. This is like a posterior probability. So always the probability, the result is uncertain. We cannot predict. But we know the two things, either yes or no, only we know that. So the same principle here, the probability, we are going to find the probability of the yes case. Similarly, we can find the probability of the no case. There is this conditional probability, or there is this posterior probability here. How it is determined is with the help of this Bayes theorem. There is the probability of F given C. There is F given C means C is a conditional probability. C is a label. I said right. So the class label yes. So how many input variables are, how many input values, how many rows in the table are having the label yes. If the label is yes means how many yes we have to count here and find the probability. This is called as the prior probability. We can easily find from any given data set. It's already known. We can easily find it from a CSV file or directly from a table. And this it's multiplied with the probability of C. Probability of C is it's actually there is the probability of the label. Totally how many yes is there and how many no is there. So we can easily identify the probability of the class label divided by the probability of this, all the number of samples. That is the meaning of this P of F. So this is a basic concept behind this Bayes theorem. This Bayes theorem is directly applied to the classification of data using Bayesian classification. So I said I explained the same thing. Bayesian rule following here. So this is the straight-side Bayesian inference. There is initial probabilities and this posterior distribution. Everything is said explained. And this is this. Okay. So before classifying this, we have the familiar concept behind that probability means definitely it may happen or may not happen. So uncertainty is there. But we have only two outcomes, either yes or no. So here all the output values, the range is there. So when we solve this kind of problem, we get this value, the output for the case of posterior distribution of the yes case and also for the no case, we get the distribution values or the probability values between the range of 0 to 1. So always between the range of 0 to 1 because it's a probability, right? So the value should be between 0 to 1. And here, what are the variables are applicable? In the case of Bayesian classification, the Boolean random variables, true or false, can be used. Discrete random variables can be used. That is, here, you can have, for example, if you are taking a weather feature or the weather attribute, where we have so many values. The climate may be sunny or rainy or cloudy or snow. So for each value, we can find the probability. The probability of weather given rainy. When there is a rainy season, what will happen to the weather? So similarly, for everything we can calculate, but the value differs based on the data we have taken. Accordingly, we calculate the probability. So we can approximately guess based on highest probability only will happen. Out of these three, probability of weather equal to rainy, then probability of weather equal to cloudy, and probability of weather equal to snow. Calculating all these probabilities and find the highest probability wins last. And the third type of variable is continuous random variables. So the continuous random variables, here the temperature has continuous values. There is we can't have any we can't have a whole number. So always the temperature will be of some kind of varying, 31.5, some kind of that is the real numbers. That is the meaning of continuous random variable, like the height of a person, weight. These are all the examples of continuous random variables. So these variables are involved in the Bayesian classification. Okay, now I will explain the basic working principle of this Bayesian classification with a small data set. There is a adult data set. Actually, this is very popular using machine learning repository data set. Normally, it is used in the many research papers. You can easily find. And in the I usually prefer this example to my students also for easy understanding. This example is very, very easy one. So here we have a table. Just take an example. We have various features like age, income, student, credit rating, and bias computer. So there are various features. So I am assuming that over these various features, I am taking this bias computer feature as the target. Bias computer is a target feature. I am setting this is the this attribute is going to decide a hypothesis. It will know whether the person will buy the computer or not. So this is the hypothesis specific attribute or the target attribute. So this attribute has various labels. Here, since the binary classification, so here only two labels only we can found, yes and no. Only two values are there. So it's called as, so we can apply only binary classification over this data set. So this is the target attribute bias computer. Just imagine the class label 1, C1. This is the bias computer equal to yes. I'm checking this is the class 1. C1 means class 1 equal to yes, yes label. And class 2 is bias computer equal to no. If the student not buying computer, then the label is no. So now we have two labels, yes and no. There are two classes in this data set. Now my question is, I want to classify a new sample. The sample values is, there is a new student. For example, a new student, his age is less than 30. Income is medium income only there. And it's a student category. And its credit rating is also fair. So now I want to classify this person whether will buy a computer or not. So I want to provide the label yes or no. So we can either provide the value, that is we have to calculate or we can predict the value of this new sample. That is x equal to age of less than equal to 30. So this new sample is classified as either yes or no with the help of Bayesian classification. This is the target we are going to find out. Okay, now first I can calculate this finding of this probability of x given c. This is I am going to find the prior probability. This is the prior probability. So probability of x given ci in general is given ci. So here we have the I value is 2. We have two classes. So C1 is yes and C2 is no. So for each class in general is given. So for first I am going to find this probability of age equal to less than 30 given bias computer equal to yes. So I will calculate how many values are there for this type of category I will find. So the meaning is there are yes category in the table. There are yes category. There are 9 samples are there with yes category. Out of 9 yes categories, only 2 persons, only 2 persons are under less than 30. That is the meaning of 2 by 9. I'll show this. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 yes cases, 9 yes labels are there. For this 9 yes cases, less than 30, less than 30 is only this one and this one. Only 2 samples, only 2 rows are having this less than 30. So I have the probability 2 by 9. It's 0.222. Similarly, I am finding probability of age less than 30 given bias computer, no. So who are all not buying computer when age is less than 30? Here also I am counting how many no cases first. There are 5 no's. 1, 2, 3, 4. And the last one is there 5. So there are 5 no cases. So out of 5, only 3 are less than 30. Only 3 are less than 30. So in the no cases, we have to parallelly check less than 30, 1, 2, and again here one is there. So for the no category, there are 3. So it is 3 by 5, it's actually 0.6. So next time checking the probability of income, medium income, given the bias computer, yes, I am checking. So similarly for total 9 out of 9, I am finding that 4 cases only of the medium income. Next, similarly find the probability of income medium bias computer, no, I am finding. So for the no cases, the same thing. Here you have to check this income attribute, we have to see this income attribute and bias computer, we have to look on that. Then find the probability. Next category is probability of student equal to yes, whether the person is a student and bias computer yes or not. So check the student category, student attribute and also the bias computer attribute. And similarly, if it is no, bias computer no, then what will happen? Then one more thing is that their credit rating is fair, then they will buy the computer. Credit rating is fair, but they won't buy the computer. So next time checking with this credit rating with the bias computer. These 2 attributes I am taking. So similarly, I am finding the probability of all the cases. So why I am checking, why I am taking all these things? I have taken this age less than 30, medium, student equal to yes, credit rating is fair, is actually our required. This is what I want to find. So it is given here. So for each attribute, I am checking for the yes case and also I am checking for the no case. For income medium, I am checking for the yes or no. For student equal to yes, I am checking for yes or no, whether they will buy a computer or not. Similarly, credit rating attribute, I am checking buy or not. So this is what we done. We found all the probabilities, all the prior probabilities. We can easily find from the given data set. So next my question is, we are going to find that age less than equal to 30, income medium, student yes, credit rating is fair. I want only this category. So what I going to do is take the both yes cases and no cases, because we are going to find bias computer yes or no, right? So the bias computer yes or no, for this I am taking this who are all having this bias computer yes. So in this case, the bias computer yes, we have this age less than 30, so the value is 0.222. I am taking this value, multiply with next yes case is this one. This is bias computer yes. So multiply this 0.444, multiply with next yes case is 0.667. Take all the yes case probability only here, multiply everything, and we get the value of 0.044. Similarly, next calculate the probability for that no cases. So the no cases, multiply all these no cases, 0.6 into 0.4 into 0.2 into 0.4. We get 0.019. So next, finally, this is the case for this. This is the case going to determine the posterior probability. Final answer. So multiply, there is probability of x given bias computer equal to yes into probability of bias computer equal to yes. So for this, this value is probability of bias computer equal to yes. So we are going taking the probability for this is here 0.044 into then the probability of bias computer equal to yes. So multiply these two values, we get this value of 0.028. Similarly for the no cases into probability of bias computer no, then we are calculating this probability. It's 0.009. So this probability we are taking from the table. Directly from the table we can get it. And when you multiply these two, we get these results, two probabilities we are getting. Next thing is you have to decide which one is the right, which one is needed to come for a decision, right? So I can assign only one label, either yes or no. So here find the highest value, highest probability value is 0.028. So this is the highest value. So I will assign the label is the new sample. So the new sample X is there. The new sample age less than 30, income medium, student S, credit rating fair. This new sample is assigned a label yes. Okay, with this simple example, next I move on into text classification. So what is the meaning of text classification first? So text classification is a process of categorizing a text. So you may have a text in a document or in a file. We are going to categorize the given text to some groups. That is, for example, in the case of nowadays, we are seeing the text in many things, right? Like social media, Twitter, then the e-content, then there is news articles, product reviews. When the online shopping, product reviews are there. So many places you can find that text data. And we know that text data is not having any proper structure. It won't follow any row column format, right? So always it's a unstructured data. So text nature will be of always unstructured data. So the text is unstructured one. So our goal is to here I'm going to analyze the text in the form of a classification purpose. How the text can be classified. For example, the task like sentiment analysis, natural language inference. So that is meaning is the what the content is going to say about what is the emotion or what is the sentiment behind the text document. That is very important for analysis. So this text classification is mainly for getting or extracting the concept or the sentiment or the inference behind the text document. That is called as text classification. So when we go for this type of text analysis, what's the purpose when we do this? Normally, in a case of product review, you can take a best example, Amazon, there are Flipkart, lot of online shopping platform is there, right? So we can choose our own product, then we can purchase it. So after that, while using, we may give some kind of comments. If it is good means, we will give a good comment. Sometimes if it is bad, we will give that we'll suggest to others that please don't buy these products from these things. It has features of a few things. It is not working well. We'll mention everything. So if it suppose it is working good means no issues. We'll appreciate the company or the suppliers and its various features we usually explain. So these are the some kind of positive maybe there or maybe negative maybe there. So this feedback or the rating may be for the product, the customer may give a good reviews or sometimes they may give a bad review. So both are equally probable. So, so in this case, we go for that, how to identify whether it's a good review or it's a bad review, how to analyze. So the solution is text classification. So the text classification means from the given set of taking all the reviews given by the people, collect as a single document, then those document will be applied to the machine learning model. Then we get the output that what is that? That is whether it's a good or it's a bad. We get that. So this text classification process, how it is working means this is the basic outline. There is we have a text document and we have a feature vector, feature extractor. There is initial text will be having a lot of there is grammatical verb may be there or a full stop is there, some kind of tag is there, comma. So these are all the in between. We can see that small tokens will be there in a sentence, right? So in the given document or a text file having collection of sentences, we all divide that sentence into some small chunks or some pieces. Then we go for that feature extraction. So extract the important features. Then those features will be the input for the machine learning algorithm. If it is a naive-based classification mix, the naive-based classification algorithm will be trained with those features. Then the remaining data will be useful for that model testing purpose. You can use it. So this is the basic classification model. Next, text processing. So normally, when you take a raw text, I told that it's actually an unstructured format. So there is no standard way of for that data. That is, we can while tapping, we can have a comma or dot, multiple dots we may provide, exclamatory symbol we may use, question mark symbol. So this all happens in a unstructured text uh, uh, in a document, right? So while processing this text in a classification algorithm, machine learning algorithm, it is not an easy task. It's a highly challenging. So how this challenge is overcome? So the solution is we have to do some kind of treatments. There is treatment will be given. The initial data or the raw data will be treated or pre-processed before given to the machine learning model. So the first step, applying data pre-processing. So the second step, extract all the important features. Then we go for supplying these machine learning features, this text and document features supplied to the machine learning model, train the model, and finally test the model. So this is the case. This is just 3 simple steps to perform text processing. So where and all this text processing is applicable? So there are various places like sentiment analysis, information retrieval purpose, machine translation. So the various domains, there are so many use cases. So where this text pre-processing is mandatory. So next, we can see each step one by one. First step is data pre-processing. So the data pre-processing, I told that the pre-processing means before applying into this machine learning model or the naive-based classification model, we have to treat the data or pre-process the data into standard form. So we know that text means it has fully words, right? The words. But in case if it is English means we got English words. Similarly, the same thing can be happen for Arabic or any type of words we can apply. So the what to do is the first step is the data pre-processing. So here we have to do that tokenization process. This is a very, very basic step. So tokenization step divides or converts a given long sentence into set of words. It just breaks that sentence into individual words. That is the meaning of tokenization. Then the second thing is the removal of unnecessary punctuation or the tags, comma, semicolon, all those things we can remove. That is not necessary during the analysis process, right? The classification process, it doesn't need all those things. So simply remove all those unnecessary punctuations, everything. So next thing is removing stop words, removal of frequent words like usually we have this the is some kind of words, right? Those words are repeated we are using also because we don't want those things. There is not much is, semantic is there, not much meaning is there in those words. So they remove those stop words and the frequent words also. That is the next step. And next is stemming. Stemming is a very important thing, very important pre-processing step. Stemming and lemmatization. So on the stemming, the words are reduced into a root. That is called a stem. So we are converting the individual word into its equivalent stem or the root. How we can achieve this? Either by removal of prefix or by removal of a suffix. We have to make it to a final stem word or a root word we have to find. But lemmatization is somewhat different. Here also we are going to reduce that word, but we are going to here find a part of the speech. That is, if it is there's a verb means continuous verb means just we can remove that unnecessary words, but with the help of a grammatical dictionary. So the grammatical dictionary, I give some suggestions what part should be removed from each word. That is called as grammatization. I will explain. So the first one is stemming. So the stemming process, what is it? This removal of the suffixes or the prefixes. So in this case, I have the words studies, studying, or the example words. So here, after stemming, I'm removing the suffixes. So IES in this word, I am removing this ES, and here studying, I am removing this ING. So after this, STDUDI is one word, and STUDY. So these two are the result of the stemming process, this removal of the suffixes. The second thing is lemmatization. So lemmatization, it considers the context and converts the word into its meaningful base form called lemma. Because in the previous case, STUDI is no such word, right? It's a false. It's not a true, it's not a good one. But study is the correct spelling. But in this case, after removal of suffix, what happened? STUDA, it's not a meaningful word. So this is the drawback of stemming approach. But in the lemmatization approach, it considers a context, converts the word into its meaningful base form or the meaningful stem word we get called lemma. So it assesses the morphological analysis of the words in a context. Here the thing, same thing, same example, studying. These two words are lemmatized into study. It's a verb. Study is a verb. So it's because it has a grammatical dictionary. The grammatical dictionary gives suggestions on how to prune those suffixes and finally get a meaningful word. That is the motive behind the lemmatization. So here also one more example, changing, changed. So here also removal of this ing or removal of this ed or removal of this e. Finally, we get this a lemmatized word. We can get at this output. So this is called as data pre-processing step. The second step is feature extraction. So the feature extraction, actually the words of the text represent discrete categorical features. So that is, we can have this the given text data having set of words, right, or the sentences. We are going to convert those text data into a feature. So how this feature is extracted? So we are going to map the text file or textual data into a numeric one, into a real valid vectors. So text into vector, how it is possible. So this is called as a feature extraction. So very simple technique is called as bag of words. BOW, bag of words. So the bag of words, what we do is take a set of words or a bag of words from a given sentences in a text file. Then those words will be analyzed. It's a repetition. This, for example, in this case, the text data has the values of small dog, cute cat, second sentence, third sentence, cute dog. There are 3 sentences. So what I'm going to do is I'm going to find the bag of words for this text data. So the bag of words is like a output of this bag of words is a vector. It's a real valued vector. So vector we know that we have set of values, right? So how these values are determined for this? So here we have the words. If I take all the words in the given text data, the first sentence I'm taking this word small here and dog here, and second sentence cute is there, and again cat, it is cat, and remaining third sentence the words are repeated, so no issue. So just take all the words one time. So take the unique words from the text data and make it as a column. Okay, bag of words. So now we have the bag of words, the vector, we have the value, we have the values cat, cute, dog, small. Okay. So now we are going to provide a bag of words value or the real vectors, real value vector to each sentence. How this vector is assigned to each vector? Take the each sentence. Take the first sentence, small dog, right? Small dog is the first sentence. But in the small dog, there is no cat word, right? And no cute word. So I'm representing this small dog in the bag of words approach. How to represent? So here cat, the value is 0 because in the first sentence there is no cat word. So it is 0. Then the cute. Cute also not present in the first sentence. So it is 0. Then dog, it is there, right? The first sentence we have the word dog, so the value is 1. Then small also there, so value is 1. Okay, that's all. If the word is present in the sentence, put the value 1. If it is not present, put the value 0. That's all. So now take the second sentence, cute cat. So in this case, the cat, the value is 1, right? Because it occurs only one time in the second sentence. And the cute is 2. Why this count is 2? Because it occurs 2 times. Cute cat, it occurs 2 times. So its value is bag of words is 2. Its count is 2. And a dog, there is no such word, so 0. Small, there is no such word. Second sentence, so it's also 0. Now take third sentence, cute dog. Okay. So the cute dog, in this case, the cat word is not present. So 0. Cute is present 1. Dog is present 1. Small is not present. In third sentence, there is no small word, right? So it is 0. So look like a matrix. Actually, it's a bag of words. So now each row, we can say that small dog, one sentence, right? The sentence equivalent vector is 0, 0, 1, 1. And cute cat, its equivalent vector is 1, 2, 0, 0. And for cute dog, the equivalent or the mapped vector is 0, 1, 1, 0. So this is what the mapping is there. Now I hope you all understood about mapping of text data into its equivalent vectors. This is called as the feature extraction. So now this Bagabirds is ready, right? Actually, this is going to be the input for the machine learning model. Step 3 is actually classification. The step 3 is choose ML algorithms. So in this case, I'm going to show you a demo with this NA-based classification approach. So before showing the code, you should know the basic packages supported in Python to perform this text classification. There is a text blob, NLP, scikit-learn. There are so many packages available to support this Python version 2 and 3. And this is a sample code to perform this base classification. Here we have to provide the document, input file or the input text we have to provide, or the sentence we have to provide as an input. Then it takes the input, then how it is processed. So in this case, it takes the input, that is enter the number of documents 3. 3 means we have to provide 3 sentences as an input. So enter the first document, content of the first document. I'm giving that I watched the movie, and I'm giving the class also. There is a plus means it's a positive. I watched the movie. I'm assigning the label. The student example, the purchasing of purchase of a laptop or purchasing of computer example, I said that yes or no, right? Here I am saying that plus or minus. So in this first document, I am assigning the label plus. For second text, I am assigning the value is I hated the movie, and the label for this is minus. Negative, right? I don't like that movie. So minus, I'm giving that. The third document content text is poor acting. So here also I am giving the value plus. So positive, plus 1. This is the label. So now we have 3. Now the thing is, I want to classify another text. I hated the acting using naive-based approach. How I can going for classifying this text, because I have the document. What are the values I have? I watched the movie plus I hated the movie minus poor acting plus. I have only 3 values, 3 text with its corresponding label, right? Plus or minus. Now the task is to classify or to find the label for the text. I hated the acting. So how to find with the help of this base classification, I already explained in the first example. So the same thing will be happened here, the code. Then when you go for applying this, finally, this is a table I told, this is a Bagabirds table, right? There is the document ID is 1, 2, 3. There are 3 documents we are taking, and the acting word is not present in the first sentence, right? 0. So hated is not present in the first sentence, 0. What is the first sentence? I watched the movie. So here I watched the movie. So in this case, they also taken as 1. Suppose here it is not removed. If you want, you can remove during the pre-processing step, remove all this, those things you can remove it. But this example, they have not removed, simply given all the words, its count, its Bagabirds count is given. So acting is not there, 0, hated is not there, 0, and I is there, 1, movie is there, 1, poor not present the first sentence, so 0, the is present for 1, watch is there, 1, and this class is plus. Similarly, for second sentence, the vector is this, and its label is minus. And for third sentence, the equivalent vector is this one, and its label is plus. And this is the probabilities of each word for this plus. How to find this probability? I explained everything, the basic concept. How to find the probability for the positive class, how to find the probability for the negative classes. Okay, so same thing, it's applied here. And the probability of the I for the positive cases, it is found at 0.1429. And for the hated word, because why we are calculating this, I hated the acting, because this is what we have to find, right? This is what I'm going to find the label. So hated with the case of positive label, its probability is 0.0714. And for the positive label, 0.1429. And for the acting word, its probability is probability of acting given the positive label is 0.1429. So while calculating this probability, The positive class alone, we get, when you multiply all those things, we get that 0.00013890. So this is the probability we are getting for this positive class. We are going to find for the positive class. Similarly, find for the negative class also. So the negative class, the value is 0.00012863. So now after finding the probability for the each word of the sample, each word of the final sentence for the positive class and negative class, now we have two probabilities, right? So out of these two probabilities, I am going to take the highest value. So the highest value will be taken as the final probability of that label will be assigned to the text. That is, what is the text we want to find? I hated the acting. So this sentence will be assigned a probability of, assigned the label of positive. The positive will be assigned. So why means because it has the highest probability of 0.0001856551. So it is assigned as positive. So now I would like to explain the few pre-trained models to be used for text classification. So there are various large language models are nowadays popular. It's actually BERT model, bidirectional encoder representations from transformers. It is a most popular model. It has almost Wikipedia words, everything is there, 2,500 million words are there. It was trained. So model is good, capable of generating the word. Similarly, this another model called as GPT, that is generative pre-trained transformers. It's also a text-based model. So normally nowadays the API apps, all the AI apps are open AI product apps are nowadays using this GPT. So it has many billions of parameters trained with this various large language models, and deep learning models were there inside this model. Pre-trained model can be useful to our research purpose for the text generation. So if you have any queries, you can ask.
Thank you, ma'am. Have you any query means you will ask the participant?
Thank you for your insightful speech. On behalf of SKP Engineering College, I extend our deepest gratitude to Mrs. Suja A. Alex for her invaluable contribution to our national level faculty development program on text analytics using machine learning. Mrs. Alex's insightful lecture has significantly enhanced our understanding of this critical field, highlighting the dynamic interplay between patents rights in India and the evolving academic and research areas in our current technological context. As we conclude today's session, we are inspired by Mrs. Alex's guidance and motivated to explore the vast potential of text analytics and machine learning in various domains. Her contribution today have not only enriched our knowledge, but also opened new awareness of research and applications, fostering a deeper appreciation for the transformative power of technology in shaping our world.
Thank you, Ms. Suja A. Alex, for sharing your wealth of knowledge with us and for being a beacon of inspiration in the field of computer science and engineering. We look forward to the opportunity to learn from the collaborate with you in future.
Thank you, ma'am.
Thank you. Thank you so much. I would like to thank Dr. Raji, Professor,
Thank you,
for
ma'am.
giving me the opportunity. Thank you so much.
Thank you. Thanks, ma'am.